Hi, this is chapter 9, section 3, the probability of a compound event. Now, we're still finding the probability, so we're still finding the number of favorable outcomes over the number of total outcomes. But now, because this is a compound event, finding the total number of outcomes can be a little tricky at times. So we're going to use two tools to help us figure out the number of total outcomes. And those two things that we're going to use is called a sample space. And a sample space is where we list all the possible outcomes and we make it in an organized list or a table. And another way that we do that is to use a tree diagram. So let's look at a couple examples here. 3 students choose to represent the class in the school assembly are shown. All 3 of them need to sit in a row on the stage. Use a list to find the sample space for the different ways they can sit in a row. So here we're using a sample space or an organized list. So we can do A, C, G, or A, G, C. Do you see how we started with A first and then we just switched the last 2 around? Now we're going to start with C. C, A, G, or C, G, A. And then for the last 2, we start with Greg or G. G, C, A, or G, A, C. So in this way, we come up with an organized list. We see that there are now 6 possible outcomes. So when we go to find probability, we know that the number of favorable outcomes over the number of possible outcomes, and we know that the possible outcomes is 6. Down here we have a tree diagram. Cars can be purchased in blue, silver, red, or purple. And if you look here, your first decision here is the first choices in the tree diagram. And then it also comes in convertible or hardtop. So if you choose blue, then you have to choose convertible or hardtop. Silver is convertible or hardtop. Red is silver, convertible and hardtop. And purple is convertible and hardtop. So this is the tree diagram, and then at the end you list the sample space. B, C, B, H, S, C, S, H, R, C, R, H, P, C, and P, H. So then by counting the sample space, 1, 2, 3, 4, 5, 6, 7, 8, you see that there are 8 possible outcomes. Compound events consist of 2 or more simple events. The probability of a compound event is just as same as the simple event. It is a fraction of the outcome of the sample space for which the compound event occurs. So let's look here. Suppose you toss a quarter, a dime, and a nickel. Find the sample space and what is the probability of getting 3 tails. Okay, so we flip the quarter. We get a heads or a tails. We flip the dime, heads, tails, or heads, tails. And then we flip the nickel, heads, tails, heads, tails, heads, tails, heads, tails. So now we have our sample space. We have heads, 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 tails, tails, tail, heads, tails, heads, heads, tails, tails. Then we start with tails. Heads, 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 tails, heads, tails, 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 heads, and tails, tails, tails. So the favorable outcome, there's only one of them where all 3 of them are tails. So the favorable outcome is 1, and then the total number of outcomes in the sample space is 8. So the probability of 3 tails is 1 out of 8. Okay, let's look at this last example here. To win a carnival prize, you need to choose one of 3 doors labeled 1 through 3. Then you need to choose red, yellow, or blue box behind each door. What is the probability that the prize is in the blue or yellow box behind door 2? The table shows that there are 9 outcomes. So door 1, red box, door 1, yellow box, door 1, blue box. Door 2, red, door 2, yellow, door 2, blue. 3 red, 3 yellow, and 3 blue. So there's two, according to what they're looking for, there's 2 favorable outcomes out of 9 total outcomes. Okay, thank you. Now, I know writing the sample space takes a while, but it's important that you write them out. Thank you. Bye.